Okay, cool. I've looked at all of these. This is an interesting one. When I first looked at this, my inclination was to treat it just like any other derivative. In other words, we would let u equal that whole thing inside, and then we would find out what du dx was, and we would just use the chain rule. But then I realized that, wow, that is a hard problem if you do it that way. What's a better way to do this problem?
Would that be to,
Let's use the rules of logs.
break that apart into the natural log of the top minus the natural log of the bottom?
You got it. So what is that equal to?
Natural log of the top is 1 over that.
Hold on. Natural log of the top is the square root of that.
Oh yeah, the square root of that.
So it's x squared plus 1 to the 1/2, which means I can put the 1/2 there.
There.
Okay.
Okay.
Minus what?
Minus x times that quantity squared.
Well, first of all, we got the natural log of x.
Yeah, natural log of x.
Minus.
Minus that quantity there, and then you could take the 2 out in front, so 2 times that quantity, or 2 natural log of that quantity.
Okay, so that's the better way to write this problem. Because now it becomes kind of a piece of cake to differentiate it. What's the derivative of that?
Isn't that just 1 over that times the 1/2, so we get 1 over 2 times x squared plus 1?
Hold on. We also have to take the derivative of the inside. What's the derivative of the inside?
X. So then we have to multiply.
2x, and the 2 cancels with the 1/2, so yeah. So that's what that's equal to.
Yeah.
Okay, what's the derivative of that?
That's just x, or 1 over x.
And the derivative of this.
The derivative of that is, we have to take the derivative of the inside, which is 6x squared. So then we have 6x squared on the top, and on the bottom 2x squared minus 1, and then since it's times 2, it's a 12x squared on the top?
Yeah. So that's...
Isn't it...
Go ahead.
Quick question. Isn't it a plus sign, natural log of x plus the 2 because it's multiplication there?
No.
No?
The reason is that everything is being divided. In other words, this numerator is being divided by both of those. So if you like, yeah, I can put parentheses around it and put a plus sign like that. But by the time I remove the parentheses, I've got minus signs in front of both.
Got it. That makes sense.
So we need to look for this answer.
Which would be the last one?
I think, yeah, the last one looks exactly right. Or D. Oh, yeah. I don't know if there is an E. I forgot to put it up.
Yeah.
Okay. So that makes the problem a whole lot easier by using the properties of logs. Because this would be a nightmare if I even had to take the derivative of the inside. Notice how hard that would be.
And that looks a whole lot easier since you...
Yeah, it was a piece of cake, actually, once we separated out all the logs.
Okay.
All right, how about this one?
this next one. Differentiate y equals x e to the x. So, would step 1 be to take the natural log of both sides?
Good. That's almost always step 1 whenever you have a variable as an exponent.
And then you would bring the e to the x down in front of the natural log, right?
Okay.
That's no longer an exponent. And then...
What's the next step? Remember, we're trying to differentiate y. We're trying to come up with a y prime.
So wouldn't it be to get y by itself?
Exactly. Well, to get y prime by itself. But how we don't have a y prime yet. How do we get a y prime?
Differentiate the whole thing?
Yeah, differentiate both sides. So what's the derivative of the left? In other words, we want to take dy dx of both sides.
So we get 1 over y prime?
Yes.
Right? And then on that side, e to the x just stays e to the x, right? And then 1 over x, so then e to the x over x. Plus c?
Hold on. Got to use the product rule.
Oh, yeah. And then the other one is natural log of x e to the x, right? Let's see, got it.
Okay. So y prime is going to be this whole thing multiplied by y.
Y.
And y is what?
X e to the x. Or x raised to e to raised to the x.
Yeah, so that should be our answer. We're looking for something that looks like that.
Which, it looks like she left off the plus c, but wouldn't that be c?
She did, didn't she? Oh, that's because she differentiated. We're differentiating, not integrating.
Yeah, yeah.
So there is no plus c.
Yeah.
All right.
So c?
Yeah. As we've learned, the multiple choice doesn't help a lot on the... I mean, you can't back solve it, really, any of them. Pretty much have to solve them and then see if your answer is on there. Okay, so we have f of x equals 2x e to the x. The graph of f is concave down when? Well, first of all, what determines concavity?
Isn't that the, I want to say the second derivative?
Correct. So what's the first derivative?
So the first derivative of 2x e to the x,
Product
that's
rule?
a product rule, right? So the first one, we'd have 2x e to the x, because we'd leave with 2, plus e to the x, because the 2x goes down to 1. Oh, it goes down to 2, so 2 e to the x.
Okay.
Yeah.
Second derivative.
Product rule again on the first term. Which
Well, we know what that is. We just did it.
Yeah, so that's the first derivative, and then plus, does that just stay just 2e to the x, or does that go to e to the x?
No, that goes to 2e to the x. Okay. So that's the second derivative, and what do we need that to be?
We need that to be, for it to be concave down negative, right?
Yes. So we need this whole thing to be negative. Well, let's first of all, we got 2x e to the x plus 4 e to the x. We can factor out an e to the x. And we can factor out a 2 e to the x, leaving x plus 2. And this all has to be negative, right?
Yeah, so less than 0.
So now we have this inequality to solve. What are your critical points?
Our critical points would equal 0, right? So negative 2?
Well, critical points are whatever makes this 0 and whatever makes that 0.
Yeah.
So the only critical point is really minus 2, because there is no x that makes this 0.
Yeah.
So the only way this whole thing is going to be less than 0 is if that's less than 0. We don't even have to go through the line chart process. We know that this is less than 0 as long as x is less than minus 2.
Which is A.
Yeah. Not even equal to minus 2, because if it's equal to minus 2, this is positive. It's the whole thing's 0, and it's not less than 0. So, all right. Now, this is a little different. This is not similar to the one we just did, even though it's natural log. We're not going to use any of the natural log rules. We're going to use substitution. In other words, we're going to use the chain rule. It's the derivative of the outside.
The derivative of the outside is 1 over that inside, right? E to the negative x to the 2.
Now what's the derivative of the inside?
E to the, isn't it the same? Well, not the same, it's just e to the negative x to the 2, right? But then isn't there the second inside of the negative x to the 2?
Alright, let's go through the way we're going to do this. Whenever you get confused about the chain rule, which is easy to do when you have multiple chains, let's define u. Okay? I'm going to let u equal e to the minus x squared, which means I'm going to be taking the natural log of u, which is going to give me 1 over u.
Yeah.
Alright, but then I have to multiply it by du dx. And what is du dx here?
Isn't it the same?
Well, it's e to the minus x squared times the derivative of that inside.
Which is negative 2x.
Oops, hold on. I meant to hit the eraser. So, I want to multiply that by du dx, which is 2 minus 2x e to the minus x squared. That e to the minus x squared cancels with that e to the minus x squared. I should find a minus 2x on there. And I do, C. You don't have answers for these. I noticed they weren't on the thing. Is that correct?
Yeah, I don't. Let me go look real quick, but I don't think.
That's all right. I'm pretty confident on all of these, so I'm not doubtful on very many. So I don't really need answers here. So this one. What would be required for the limit of f of x as x approaches 2 to exist?
What would be required if x approaches 2?
What would have to be true? In other words, when you take limits, when we talk about limits, and we talk about limit from the left side and limit from the right side, for the limits to exist, they have to be equal, correct?
Yeah.
In other words,
Yes.
the limit as we approach 2 from the left has to be the same as the limit as we approach 2 from the right, or else the limit at 2 does not exist. So let's check that immediately, because we have a non-existent on there. So what is the limit as this thing approaches 2 from the left?
The limit is that approaches 2, so ln of x when x is equal to 2. Isn't that just the natural log of from the left?
Uh-huh.
So that's the natural log of x?
Of 2.
Oh.
In other words, the limit, the limit of natural log of x as x approaches 2 from the left is natural log of 2.
2.
Well, what is the limit as we approach it from the right?
Isn't that natural log of x?
Well, we're using this second function.
Oh.
And the limit as we approach from the right is going to be 2 squared natural log of 2, or this.
Oh.
Since
I understand what I did. Oh, okay.
Okay, that is not the same as that. In other words, the limit as we approach from the left is not the same as the limit as we approach from the right. Therefore, it's non-existent.
Yeah. I understand what I did now. Yeah, that makes sense.
All right. What is the integral? I assume this is what they're trying to say.
The integral from 1 to 5e of 1 over 5 dx.
Uh-huh.
So first you have to integrate the 1 over 5, right?
The 1 over x.
The 1 over x, which is just the natural log of x. And then you plug in the 5e first, and then the 1 minus 1. So that's the natural log of 5e minus the natural log of 1. And the natural log of 1
is what? What is the log of 1? Natural or otherwise?
Isn't that 0?
Uh-huh. What's the natural log of 5e?
Well, the natural log of e is 1, so would that just be 5 then? Or does it stay 1?
Well, let's look at that. If it was the natural log of e to the 5th, yes, it would be 5. But the natural log of the product means the natural log of 5 plus the natural log of e, this is 1.
So it would be then
natural log of 5 plus 1 should be the answer.
Which is on there, that's D, so...
Yeah, it is D. Okay. Yeah, that's a little tricky. That was my first response, was to say the natural log of 5e was going to be 5. But it isn't. Notice that the natural log of e to the 5th, that would be 5, because then that would equal 5 times the natural log of e, which is 1. But the natural log of 5e is not that. It's not the same. It's a little tricky. We did a problem exactly like this last time.
Yes, we did.
In fact, I think it was the same problem.
It was the same problem, if I remember correctly.
What did we do? What did we use to solve this?
I believe we used u substitution.
Yes. The key is, what are we going to let equal to u? And
why?
why?
I think we used x plus 1.
Yeah. And the reason is that if we tried to do this without u substitution, we might try something like, well, that's x over x plus 1 plus the integral over 2 over x plus 1, correct?
Yeah.
Well, we know how to do that,
Mm-hmm.
but I don't know how to do that. The first
Yeah.
one I don't know how to do. This is not the derivative of the bottom. We can't use u substitution, so this becomes a little difficult. However, if we use u substitution and we can turn the bottom into a single entity, then it's going to be easy. In other words, if we let u equal x plus 1, well, what does x plus 2 equal?
1, then x plus 2 is u plus 1.
Uh-huh. So now we can turn this whole integral into
U plus 1 over u.
yes. And that's a lot easier to deal with because now we can split this into two partial fractions and we're fine. What is du?
Du is 1, right?
Figure out du from that
du.
right there.
So u, the derivative.
Du is dx.
Yeah.
In other words, if I go to figure out du, I get du dx equals 1, which means du equals dx. We need that because we can't use u substitution unless we can substitute for that.
Yeah.
Now, help me do this one.
So we have u plus 1 du.
Split it into two partial fractions. Remember, you can always split it into partial fractions if you have a single entity in the bottom.
So for the first one, we have the u over u, and then the second one is 1 over u du. And then the first one turns into, since u over u is 1, yeah, like you wrote, that just becomes an x, or u.
A u, actually.
Plus the natural log of u plus c, and then when we put u back in, we put the x plus 1 plus natural log of x plus 1
In absolute values.
Plus c, and then doesn't the, didn't we determine last time we did this that she counted the first plus 1 as part of the c?
Yes, and that's how we get d.
Yeah.
In other words, this c is some indeterminate c, so any time we have a c, we are fine. In fact, I discovered an interesting problem the other day. Take the natural log, or take the derivative of that.
Of that?
Mm-hmm.
1 over, oh yeah, y equals 1 over 3x
Times,
3,
which is
3 over 3x, which is 1 over x.
take the natural log of 5x, takes the derivative of that.
That does the same thing, doesn't it? So it turns into 1 over
Interesting. I never knew this until just a couple of days ago, which means the integral of 1 over x is the natural log of some constant times x, correct?
Yeah.
Well, that makes a lot of sense because the natural log of some constant times x is the natural log of x plus the natural log of c. Well, we knew that the natural log of, or the integral of 1 over x was equal to the natural log of x plus c, that c is the same as that c.
See.
They're both constants. The natural log of c is just a number.
Yeah.
And that's why this is true. In other words, the integral of 1 over x is indeed equal to the natural log of c times x. But it's also equal to the natural log of x plus c, or even the natural log of x plus the natural log of c.
Mm.
All right. What's the first thing that enters your head when you see this problem?
To break it up into two different...
Actually, that's not the first thing that enters my head. The first thing that enters my head is that I know how to integrate this. That's natural log of x squared minus 4 with only one problem. I need the derivative of the bottom to be in the top.
Yeah.
And lo and behold, it is. Almost. What I really need is a 2 in front of it. So let's put a 2 in front of it and a 1/2 out there. Now it's perfect for u substitution. What's u going to be?
U is going to be the bottom, the x squared minus 4.
What's du going to be?
Du will be 2x, which is the top.
2x dx.
Dx.
We see that right there. So now this whole thing is equal to 1/2 the integral of du over u, which is
du over u, that turns into...
what's the integral of 1 over u?
The integral of 1 over u is the natural log of u, so that's, yeah. The natural log of
And
x
this
squared
1/2 goes there, and I have a c that goes there. And there's various ways that answer could come up. It looks like c, but I could also take that 1/2 and make it square root. So it might look like the natural log of the square root of x squared minus 4. So there's always lots of different ways to represent log answers when you have a coefficient in front. You can turn it into an exponent if you want. Okay? This is a little tricky. I saw a problem just like this on the AP, the Calc AP AB exam. Incidentally, I have a couple of those online on my computer. Whenever you get ready to start preparing for that, the AP test,
Yeah.
I've got lots of, in fact, if you go to the library and check out books to start preparing for it on your own, do not get the Kaplan book. Get any book but the Kaplan book, because that's the one I have digitized.
Okay.
And I would rather, when we do these, that they're problems that you haven't seen yet.
Got it. I will make sure not to get the Kaplan.
The library has 2 or 3 of them. They have a
There's
Princeton
a ton of them.
Review and a Barron's, and so there's lots of them. And your teacher will probably give you multiple practice tests.
Theoretically.
How are we going to do this problem?
So we have e to the x over, or e to the square root of x over the square root of x. So would we just break this apart and then solve it as 2 separate ones?
No, that doesn't really help.
Doesn't really help?
No.
Because I guess then we get to just either, yeah.
At this point, you've really only learned one technique for integration, and that's u substitution, correct?
Yeah.
You haven't learned integration by parts yet.
Nope.
So we don't have much choice. There's like 6 or 7 different techniques for integration, so there might be a lot to investigate. But at this point in your class, you know it's E substitution or U substitution probably pretty much is what we're stuck with. Now, this doesn't look immediately like it lends itself to U substitution, but it actually does. If I write the denominator as this, see what I just did? Excuse me, I forgot the negative sign. Now it looks a lot like what we look for in U substitution, which is a composite function where the numerator also has the derivative of what we're going to use for U.
Yeah.
So let's go through it. What's U?
X to the negative 1/2.
No.
No.
When you think of what to make U, think of how we're going to integrate it. Can you integrate this? I can't integrate that.
No, so then make U that.
Make U this. I can integrate e to the U. That's the beauty of e to the x, is that it's the one function whose integral is the same. So let's let u equal square root of x.
Yeah.
Now what's du equal?
Du is 1/2 x to the negative 1/2.
That right there, I see right there. So this turns into what? An integral of u.
Yeah. So then we would write that as e to the u. How would we write that though? Because there's that 1/2.
The easiest thing to do to handle this 1/2 is to go back up to the original function, put a 1/2 in there, so now we have the whole thing. We have 1/2 x to the minus 1/2 dx, but I can't do that unless I put a 2 in front.
Oh, so then you just bring the 2 down, and then you have e to the u du.
Exactly, you got it. That's equal to 2 e to the u, which is e to the x to the 1/2 plus c.
Which is a.
Correct. This is an odd limit problem. And I say odd because the only hard limit problems are when you end up with 0 over 0. Do you end up with 0 over 0 here?
Yeah, you could.
How? Just do direct substitution. What do you get?
Well, if we put a 1, that's 1 over 0.
No. Oh, exactly.
Oh, yeah.
What's the limit of that?
It doesn't exist.
Exactly. It's infinity. Non-existent. I don't really like that answer. I prefer infinity. They're not always exactly the same. So what's the general formula for average value?
The average value is the one endpoint minus the other endpoint, right?
Well, it's going to be the integral of the function from 1 to e.
The other, yeah.
But
I'm just going to integrate.
that's the total area under the curve. It's not really what they want. They want the average value, so we have to multiply that by 1 over e minus 1. In other words, 1 over b minus a. The general formula for average value is 1 over b minus a times the integral from a to b of your function. Right here is what you want to memorize.
Got it. I'll write that down.
And every test I have looked at for the AP Calc test has an average value question on there. So you definitely want to know what average value is, the general formula.
Because that's one question that you can then guarantee yourself getting.
Yeah, well, you might run into it a couple of times. Who knows? So now we have to integrate this.
And to integrate that, since I only know U substitution, I'd assume that's how we would be doing this.
No, actually not.
Okay.
Distribute the numerator.
Then we get 3x squared minus 6.
And now split that into two fractions and it becomes easy to integrate.
We have 3x squared over, that is 3x squared over x to the third, and then plus 6 over
minus
6 over
6x to the minus 3. And so what is the integral of the first part?
Natural log of 3 natural log of x.
Which is natural log, yeah, we'll write it like that, because maybe they'll have it natural log of x cubed, same thing.
Yeah.
And what is this?
And that other one, we add 1, so that's negative 2. Negative 3x to the negative 2.
What's this sign?
Minus. That changes to a plus, doesn't it?
And we're multiplying all of this by 1 over e minus 1. In other words, there's the 1 over b minus a. So let's see if we find that answer. No multiple choices on this. I didn't even notice that when I looked at this the first time. Okay. We don't need a multiple choice. As I said, they don't generally do that much good. They're not that helpful. So this was easy enough to do.
Yeah.
It kind of looked like a U substitution to me the first time I looked at it, because I saw this 3x squared and I saw the derivative of this was going to be 3x squared. So actually I could have used U substitution, but I don't think it was the easiest way to do it. I think splitting it up into two fractions turned it into two integrals that could easily be done without any kind of U substitution. All right. Before we look at the next one, let's talk about the 3 rules you need to know.
Okay.
And there are actually 3 that are difficult to remember for me, because you don't often do anything but natural log. What's the derivative if y equals natural log of x? What's y prime?
Y prime is 1 over x.
If y equals log base 5 of x, what is y prime?
Not sure.
That's the one that I have a hard time remembering, because I don't work much in anything but natural log. Well, it's actually pretty easy. It's also 1 over x, but in the denominator goes natural log of 5.
Oh.
Okay? So
Okay.
you want to memorize that because you need it for problems like this. And the other one, let's talk about, as long as we're talking about memorizing these, is if y equals 5 to the x, what is, well, if y equal e to the x, y prime would be e to the x. But if y equal 5 to the x, what is y prime?
That's, yeah, virtually 5x.
Now, compare this to that. Notice the similarities.
Yeah.
In one case, the numerator gets the natural log of 5, and in the other case, the denominator gets the natural log of 5. Otherwise, it behaves exactly like natural log of x and 1 over x, or e to the x. So whenever it's not natural log, or it's not e to the x, you have to take the natural log of whatever the base is and either divide or multiply by it.
Got it.
All right? So try to remember this that I have circled and this that I have squared. So if g of x equals x squared log base 3 of that, what's g prime of x equal to?
So we got the product rule, right? So then
Right?
the first term, x squared over natural log of 3, and then the x minus 1 to the 1/2. What that? Yeah.
Now what's missing?
Oh, the derivative of the inside, the 1, right?
Hold on a moment.
Doesn't the derivative of the inside just become 1?
Yeah, let me think for a moment. Let's see. If we have the log of 3 of x minus 1 to the 1/2, and I said differentiate that, then it would be well, if I said it was the log base 3 over of u, where u was equal to x minus 1 to the 1/2, then y prime would be 1 over natural log of 3 times u times du. Well, what is du? du is 1/2 of x minus 1 to the negative 1/2.
Oh. Got it. So I just messed up my inside there.
Yeah, the inside's a little tricky there. So that 2 goes down there. So now it should be plus this whole thing.
Yeah.
So we have this plus that. Notice that this x minus 1 to the negative 1/2 goes in the denominator, and I actually have a common denominator. In other words, I have x squared over natural log of 3 times x minus 1 to the 1/2 plus 1 over 2 natural log of 3 times x minus 1 to the 1/2. Well, if I put a 2 there and a 2 there, I have a common denominator. So my answer is 2x squared plus 1 all over this denominator.
Yeah. So
that was a little tricky, but if you ever get confused as to the insides, in other words, the chain rule says the derivative of the outside times the derivative of the inside. Well, the hard ones are the derivative of the outside times the derivative of the inside times the derivative of the inside times the derivative of the inside. Well, those aren't confusing if you start out step 1 saying what u is. U is the first inside. And then as you calculate the derivative of that first inside, you may find another chain rule is needed. And that's the way to do it, I've discovered, is always start with letting u be like I did right here. In other words, if I have any questions as to how to find y prime, let u be this, x minus 1 to the 1/2. This is an interesting problem that requires a little bit of insight to recognize it. It's helpful, the fact that we know the only methods you've been taught so far are u substitutions. So that's probably what we need to use. But it's not real clear that this is the derivative of the inside. If it was, that's what we look for. We look for the derivative of the inside to be in the numerator. Well, since I can't see that clearly right off, what's a good first step here? It's not an obvious first step, but it turns out to be the correct one.
Just multiplying those together.
Okay, what do you got? What's x plus 1 times x plus 1?
X squared plus 2x plus 1.
Now, what is the derivative of that?
The derivative of that is 2x plus 2, which...
Bingo. That's going to take care of that x plus 1 perfectly.
Yeah.
After we factor out a 2. So u is x squared plus 2x plus 1. du is 2x plus 2 dx. du is 2 times x plus 1 dx. Well,
so then we would put that 2 in there and put a 1/2 on the outside?
There's my 2x plus 1 dx. So I can substitute everything that I see there for du. And now I have 1/2 du times 3 to the u. Well, one more thing you need to learn about integration when you have a base other than e is the integral of a to the u. In other words, we know what the integral of e to the u is. It's e to the u. But the integral of a to the u is, oddly enough, a to the u divided by natural log of a. A little bit similar to what the derivative of the natural log was. In fact, it's exactly the same. Why is that? Because the natural log is the inverse, or I shouldn't say natural log, the log is the inverse of this, and integration is the inverse of differentiation. So when I take the derivative of log base A of x, I'm taking the derivative of that, I should get the same thing as taking the integral of that, and I do. Well, not exactly the same thing, but you can see the similarities. In other words, for memorizing it, this is the third thing you need to memorize. I wrote the other two, and both of those had to do with log functions that weren't base e, just like this one. If it's e to the x, we both know what that is. We know how to take the derivative of it. We know how to take the integral of it. But taking the derivative of log base anything other than e comes up so seldom that it's easy to forget. But anyway, this is what we need, and that's what we're looking at in order to do that right there. So what is the derivative, the integral of 3 to the u du?
Oh, the integral of that, so that's 3 to the u over natural log of u, right? Oh, natural log of 3 to the u?
Natural log of 3. Not
Natural
natural log of 3 to the u, just natural log of 3. In other words, the only adjustment we need to make between e to the x and some number to the x is to divide by the natural log of that number if it's anything other than e. Notice that if this was e to the u, I'd still be dividing by the natural log of e, but that's 1. So in a way, this is the general formula. And we still have the 1/2. So our answer should be that. So never overlook the obvious. The obvious being to expand the x plus 1. Because once you expand it, you recognize immediately that the derivative of it is this, a multiple of this, or a factor of that. And that's what you look for when you go to take derivatives. Or, I'm sorry, integrals using u substitution. You always look for the numerator to have the derivative of the inside in it. What's the general formula for, let's say this wasn't the square root of x, but just this x. What would h prime be?
H prime would be, for arc sine, isn't that -1 over, -1 over 1 minus x squared.
Okay. So if I put a 1/2 there, what's going to be the effect?
You put a 1/2 there. Does that just become 1 over... I'm not sure what the effect is.
Well, for starters, that.
Yeah.
That's the derivative of the outside.
Yeah.
Well, what's the derivative of the inside? Because u is going to have to be that.
So then you would put that in the top. You'd have 1/2 x to the -1/2. So that's 2 over x to the 1/2, yeah.
There's our answer.
Got it. You just gotta multiply it again.
Yeah. In other words, just it's really This one's quite simple because it's the derivative of the outside times the derivative of the inside. And there's only one inside. Okay, I think 15 may be the last one we have time for. And 15 is something else that really kind of needs to be memorized. Let me give you the general formula. You might recognize this as it looks very similar to the arc sign, right? In other words, if this was a 1, if I said, what's the integral of du over the square root of 1 minus u squared, you'd say arc sine. Right? We just went through that.
Yeah.
Okay, so this is a little different because it's not a 1 here. But there's a formula for this. It is the arc sine of u over a plus c. In other words, it's very similar. If a was 1, then it would just be the arc sine of u plus c. But in our case, a is 2. A squared is 4.
Yeah.
So the integral of dx over the square root of 4 minus x squared is going to be the inverse sine of x over 2 plus c.
So that's easy as long as you memorize that.
Yeah, exactly. This is all memory.
And then notice that 4 is 2 to the c squared.
Yeah, it's not completely all memory because you could actually work it out. Let's just investigate that for a moment. How would I turn this into what I recognize? Well, how about if I divide top and bottom by 4? Well, this 4 can go inside as a 2.
Yeah.
So then I have 1/4 on the outside times 1 over, my logic is going to fall apart here, I think, but yeah, just memorize it. That didn't go where I thought it was going to go. In other words, you just need to memorize it. You're going to see problems like this, and they're not, rarely is there going to be a 1 there. So you're going to have to know how to handle it when it's not 1. And in fact, this might not always be x squared. It might be x over 2 squared. And then the u and the a would be different.
Yeah.
All right. Let's call it a session with there. I hate to run, but I have to. I know we didn't get quite through everything, but the rest of these aren't that hard. I've looked at all of these, and they're very doable.
Yeah. Thank you.
Okay.
Talk to you.
All
Talk
right.
to you next week.
Okay. See you then.